See if it works.
If you send it to
Share it with
like
me.
last night, yeah.
Okay.
Yeah. So if you sent shared it last night, I've sent that to you.
I was just making sure that I was on the right thing.
Good call. All right, less than 2 minutes. Do some attendance here. Van Cross. Lindsay's here. Kayla's here in red. Extra credit. Reed, Hemmings, Bowers, Asbury, Couture's here. Right, yep. Felder, Hudson, Burdette, Newton, Massey, Richardson, Cedric, Rice,
Share.
and red, right?
Yep.
Midkiff is here. Eric, Hodges is here in red. David, Debbie, she's here. Okay. Everybody, that's Debbie. That's my middle daughter. Yesterday was taking her to school at 8. I had to work from home, so there she is. Actually, that's yeah, true. My wife has to work. And, all my in-laws are out of town, so I will be watching this one. So here we are. Sports biology. Well, we got less than a minute. A couple more people will be here. Again, I'll remind you guys that the final, and I haven't verified this, but I will soon and share it with you. The final should be on Monday. Obviously, not a few days from now, a week, a few days from now. It should be at 8 a.m. I forget exactly how long, but you should have a lot longer to take it because it's going to be about twice as long as the other exams. Remember that the first three, about 50 questions are going to come from the first three chapters. First three exams, verbatim. I'm going to take them. I'm not going to reword them. I'm just going to take them, copy them, and paste them. And then about 50 questions are going to come from the last three chapters from the study guides, as usual, where I take them and I reword them. What else to tell you about that? Like I mentioned before, if you need more time, or if you just don't want to take it on a Monday, I'm going to be really flexible with this because I don't know what other classes you have. So if it would help you to take it on Wednesday or Friday, whatever, I don't care. Just make sure you let me know beforehand. You can't not show up online on Monday and say, oh yeah, I wanted to take it Friday. You can't do that. If you miss it without telling me, you miss it, you get your 0. But if you want to reschedule it before that, we'll do that. So any questions about the final? All right. What else to tell you? Get this one. So this weekend is the last weekend for independent work. It's all due on Sunday's the last day. So, make sure you get that done. That's it. Not much else to say about independent work. I posted something recently that I've really been fighting with artificial intelligence. That ChatGPT is a real thorn in my side. And I've been trying to think about how I can make sure people aren't using it, all that stuff. So hopefully you guys saw my most recent announcement. If you're going to use it, I think that's the way you should do it, the way I should. One, I'll have no way of knowing you used it if you do it that way. And two, you might actually learn something. If you really want to avoid that at all, just write short papers, like I've been saying for a while. Just think of a question, look it up and answer it. Why are cats an invasive species? According to this website, they're an invasive species because of this. Turn that in. That's a paper. It's not worth much because it's so short. Just do a bunch of those. What else? On that note, again, because you guys are about to learn, especially if those of you who haven't turned any papers in, I'm really picky with your sources, and now you know why, right? Because of artificial intelligence. If there's anything in your paper that you can't link to a source, I'm not going to accept your paper. You could be like, you could write a paper about why deer hunting in West Virginia is good for the environment. And you may say something like, there's a lot of deer in West Virginia, which we all know to be true, but you better have a source that says exactly how many, right? Show me somewhere on the internet that says there's a lot of deer in West Virginia. It's the only way I can make sure that you were writing these papers, or at least that if ChatGPT wrote your papers, it fact-checked everything. Make sense? Now you know why I'm being so picky, and I do apologize. Anyway, before we get started, let's do one more attendance. David, Eric, Cedric is online. Richardson, no. Massey's here in red. Newton, Burdett, Hudson, Miller, Asbury, and then Bowers is here. So everybody's here to be counted for, right? All right. Let's quickly jump back into it. We do have to go quickly. We're running short on time. So I'll remind you again, going through this quickly, but if we need me to explain something in more detail, just maybe during office hours or some other time, we can talk about this. I've got to fly through it. We left off talking about different cycles. The last cycle we talked about was the nitrogen cycle. And remember, mostly for these cycles, whether it be carbon or phosphorus or nitrogen, for the exam, you need to know where the abiotic reservoir is. The abiotic reservoir, which is where it's stored in non-living things. And you need to know how it comes out of the abiotic, or how it goes back and forth between abiotic and abiotic. So the last thing we talked about was nitrogen. The major abiotic reservoir is the atmosphere, but also the soil. The atmosphere is the big one that we talked about because the atmosphere is mostly nitrogen. You need to know that the process by which we get nitrogen out of the abiotic, into the biotic is called nitrogen fixation. So remember, like the same way that carbon comes out of the abiotic via photosynthesis, nitrogen does it via nitrogen fixation. Of course, like I said earlier, you don't need to know the fact that technically nitrogen gas is N2, and then technically it's converted to NH3, which is then converted to NH4 plus. You don't need to know that. Just know that nitrogen comes out of the atmosphere in a process called nitrogen fixation. We already talked about this. You might need to know, but probably not. Generally speaking, when you think of nitrogen fixation, you should think of bacteria. Those are the living things doing this. Just like with photosynthesis, it's usually plants, right, or algae that's doing it. So again, this is where we left off on Friday. Just one quickly, we've already said all this. Here's a picture of everything we said. Again, I don't recommend studying these pictures because there's more details than you need to know, I think. Which is good, actually. It would be good for you to learn it all, but if you're really focused on the final exam, because we're on such short time, then you don't want to study this because it's very, very complicated compared to what you need to know. But again, the major abiotic reservoir is nitrogen in the atmosphere. The process that takes it out is called nitrogen fixation. And then the opposite of that, but I'm not going to ask about this, is called denitrifying bacteria. So there's also nitrogen in the biotic realm that then gets released by denitrifying bacteria. But again, I'm not going to ask you about that. So any questions about really quickly. Humans have been disrupting the nitrogen cycle by adding more nitrogen than the natural processes do. Meaning, we are, obviously naturally, nitrogen is coming out of the atmosphere due to the nitrogen fixation. But humans are getting involved, and we're doing it quicker than nature does. I'm not going to ask you about this, so we should put a line to it. This is all just for your own knowledge. But the two major sources of nitrogen from humans anyway comes from the combustion of fossil fuels. Like so when we burn coal at John Amos, or when we drive our gasoline-powered vehicles to get here. And of course, agricultural practices, and we're going to talk a little bit about that here in a second. The agriculture. And your book also points out, not that I'm going to ask this is a good question for my bio and weight class, but for class, it's not that important. Some of this nitrogen does escape to the atmosphere where it forms something called nitrous oxide, which contributes to global warming. So, yeah, it's not good. The first word for attendance is global. Anyway, any questions about this slide? As far as the exam is concerned, that's important. All right. Which brings us to nutrient pollution. It's a good segue into that because I basically already started talking about that when I was talking about the negative side effects of nitrogen. Your book, before I can introduce it to you, your book points this little fact out, that the growth of algae is limited by low nutrient levels. So specifically, it's low on nitrogen and low on phosphorus, right? That's what keeps algae from growing too much. It has plenty of water, obviously it's in the water. It has plenty of carbon dioxide, because Lord knows we have enough of that in the atmosphere. So those are the two limiting factors. And remember when I talk about limiting factors, I use the cookie example, the sugar cookies, right? Like if you have a warehouse full of flour and a warehouse full of eggs and vanilla, but you only get 12 eggs a day. Obviously, eggs are your limiting factor. You've got all the ingredients you can use for the eggs. So yes, these are the things that's limiting algae growth, which is good because we don't want too much algae. And I'll tell you why here in a second. But what happens is humans use a lot of nitrogen and we use a lot of phosphorus. Therefore, we put it into the ecosystems, and then that screws things up, and that's what we're about to talk about. So this slide is merely an introduction to what we're about to talk about. There's nothing on this slide, so we'll do an exam. Here's a picture of an algae bloom. It's kind of hard to, well, you guys can see it. You can see how nasty and green that is. And obviously that's gross. And so you could think of this from monetary terms. Also, you can see here some jet skis and some boats. Clearly this is a touristy area where people like to use the water. So even just in terms of money, that's bad, because that's probably bad for tourism. And probably wherever that is, probably relies on tourism money. But it's more important than just money. Let's talk about why. First thing we're talking about is phosphate pollution. Yeah, I'm going to talk about all this, but I'm not going to ask you any questions about this. So you've done the poison water videos in lab, right? Yeah, you guys did that, didn't you? Yeah. So you're already familiar with this. And basically everything you learned in that video, I'm teaching you again really quickly. Again, I'm not going to ask any questions specifically from this. But where does this phosphate pollution come from? It comes from fertilizers, like we mentioned earlier. If that's the limiting factor for plants, which we mentioned earlier, and that's why we put it in fertilizers. But then, obviously, when we put it in fertilizers, plants don't use it all, so it makes its way back to the oceans in ways you've seen in that video. Also, and that's the big one, as far as what you guys know, not for the exams, it comes from runoff from animal waste. Again, I'm not going to ask you that, but this is basically what that whole first half of that video was about, right? All that chicken poop. So there you go. Also, it comes from sewage treatment plants. Of course, that was mentioned too. The Blue Plains, the sewage treatment plants. So yeah, we're getting all these phosphates from all this stuff. Obviously from our own poop, basically, but also from things like dishwasher detergents. This is, even though I'm not going to ask questions about this specifically on the exam, this is a good independent work topic. Because obviously I haven't listed much here. Where does phosphate pollution come from? Fertilizers, animal waste, and sewage treatment plants, right? So you can look up some other stuff. Where else is it coming? Or if you wanted to, like specifically, which animal, livestock are worse, right? Which are better? Or for sewage treatment plants, what other stuff other than dishwasher detergents and human waste? All those things you can do. Anyway, phosphate pollution of lakes and rivers results in the growth of algae inside of bacteria. So again, as far as the exam is concerned, none of this is important. I'm not going to ask you how to do this. Next, we talk about nitrogen pollution, and as far as we're concerned, it's the same thing. Obviously, nitrogen and phosphorus are very different, but they're coming from similar places, and they result in a similar outcome. As far as we're concerned, there's really no difference between nitrogen pollution. Let's talk about it very quickly. The major source of nitrogen pollution is fertilizer, right? Just like phosphorus. Because again, we need fertilizers for plants. Nitrogen for plants is often a limiting factor, so we put in fertilizers and we give it to plants, and then that is then bad for the environment. Then your book, for some reason, gets specific on this one. It talks about the fertilizer we apply it to crops, lawns, golf courses, all that stuff. So this is even relevant for us, even though what their book is talking about the dead zone in the Gulf of Mexico. And then the video you watched was the dead zone in Chesapeake Bay. But this is relevant to us. We, here in West Virginia, affect what happens in the Gulf of Mexico. So when Berry Hills puts a bunch of fertilizer down on their golf course, then it rains, that drains into Davis Creek, which then drains into the Kanawha River, which then drains into the Ohio River, which then drains into the Mississippi River, which then hits the Gulf of Mexico, and we are contributing to the problem. All because we like to do a little bit of golfing in West Virginia. Anyway, if anything, if there's anything on the side you need to know, it's this, what a dead zone is. And you learn about it in that video in lab, and basically it's when you have too much, we're going to focus on nitrogen, but also a little bit of phosphorus. nutrients from the water. So you have algae blooms. Well, it sounds like a good thing, right? You do hey, nitrogen, nitrogen's good because plants are good. Plants need nitrogen. So you think that's good, but it's not because, again, we have these algae blooms. And then what happens is that algae dies, and then the bacteria that decomposes the algae uses up all the oxygen of the water. So therefore, things die. Everything dies because of that. So again, this is kind of counterintuitive. You would think fertilizers are good. Growing green things is good. It normally is. But in this case, it's not. Anyway, any questions about this slide? I guess I could do the next word for dividends. Dead. Sort of like that fish. Either that or it's just something. So here's a picture of what I'm talking about. All right, so here's the Gulf of Mexico. And here's about where we are. So that's what I was saying. Like I said, everything you do, everything I do, right? I can see the Canal River from where I live. So if I were to fertilize my yard, which I don't, it would drain off into the Canal River and make its way down to the Gulf of Mexico. Anyway, that's a dead zone in the Gulf of Mexico. Another good independent work topic. So again, the video you watched talked about a dead zone in the Chesapeake Bay. The book is giving you an example of a dead zone in the Gulf of Mexico, specifically at the mouth of the Mississippi River. Where else? Where are some other examples of dead zones? And also, you can look up their impact. Like, obviously, you know things are dying. That's bad. If you want to get specific, like, how much money is that costing tourism and fishing industry in this area? Or, as you already know, like, how much money it's costing the crabbing industry in that area. So that brings us to the last of the 4 main bullet points of this chapter. Hopefully we can finish it today and then do a little backwards action and then finish up chapter 19 next week. First thing we're talking about is the conservation, restoration, biology. Right? That's basically what this is all about. As you might guess, I've been hinting at it for a while, and I'm sure you know already, many environmental problems are caused by humans. That's not going to be a test question. That's just not common sense, right? I would say most environmental problems are caused by humans. Again, I'm only putting it next to it to indicate I'm not going to ask you about these things. This is just an introduction to what we're about to talk about. So ecological research, or the Ecological Research Foundation, is looking for finding solutions to these problems that humans have created, like so we can prevent them, but also reversing problems, right? It's a two-pronged attack here. We want to quit doing the bad things we're doing, so we need to figure that out. And we also have to figure out how to fix the damage that we've done. And that's what we're going to talk about next slides. Which brings us to the first word you might need to know for the exam, which is conservation biology. It's a goal-oriented science seeking to understand and counter the loss of biodiversity. So basically, again, like I was saying, this is sort of like preventing the problem. And then the next one, restoration ecology, basically about fixing the problem. And that's according to your book. If you were to look this up in different sources, that might be explained a little bit different. And you can if you want for independent work. This is how your book defines it. There's some other sources. How do other sources define conservation biology, restoration ecology? Then there's even something completely different called preservation. It's a neat little relationship between conservation and preservation. To a layman, that sounds like interchangeable words, but they're not. You can look that up for different work as well. So again, probably these questions I'm not going to ask you about on this. I'm not going to ask you about this on the exam, but if I do, just think conservation biology is all about like preventing the problem, and restoration ecology is all about fixing what we've already done. Basically, that's good enough for the exam. I could give you an example here. So, can anybody tell what this is? This picture, it's a little bit harder to see here than it is on my screen. You guys tell what that is? It's a coal mine, it's strip mining, right? So, the mountaintop removal. So, conservation biology would be like, all right, how can we get coal without destroying as much of the mountain, basically, as we can? And restoration ecology would be more like, all right, we've already destroyed this area. How can we fix it, right? All right. Let's talk about biodiversity hotspots. This is a term you should know. Probably going to be on the exam. It's pretty simple. Conservation biology, well, this is just an introduction. The slide is an introduction to what I'm about to tell you, so you don't need to write anything down. The conservation biologists are applying their understanding of populations, communities, ecosystems, all the dynamics of those three in establishing places like parks, wilderness areas, and other legally protected nature reserves. So I chose this picture because this is actually a legally protected nature reserve in West Virginia, Cranberry Glades. It's really cool. You can go there. They've got a boardwalk and you can see it. If you get permission from the federal government beforehand, you can actually go on to Cranberry Glades. And we did that once back when I was a student here. It's really neat. I had time to talk about it. But anyway, again, this is just an introduction to what you need to know, which is this. Conservation often is focused on biodiversity hotspots. You need to know what a biodiversity hotspot is. It's a relatively small area that has a relatively large number of endangered or threatened species and or a high concentration of endemic species. You need to know what endemic species are. Those are species found nowhere else. So you can look that up for West Virginia too. Where are some biodiversity hotspots in West Virginia or anywhere? West Virginia is very relevant. Where are some biodiversity hotspots here? What are some endemic species? And maybe you can prove me wrong, but if I remember correctly, I don't think there's any endemic species like endemic to West Virginia. But I'm pretty sure there's some endemic species that are endemic to the Appalachians, which are obviously we're part of. I'll look that up in a minute. Anyway, so that's what a biodiversity hotspot is. Remember, it's a multiple choice exam. So when you get that question asking you about what a biodiversity hotspot is, make sure you can check off both of these things, right? So there's a large number of threatened and endangered species and also maybe some endemic species. So if it's just a small area with a lot of species, that in itself is not a hotspot, right? Those species need to be special, basically. Any questions about what a biodiversity hotspot is? All right, the next slide, I'm going to show you a picture of where some of the hottest biodiversity hotspots are. You don't need to know this for the exam, this is for your own knowledge. So again, there you go. And notice we don't even show up on this map, but there are biodiversity hotspots where we are. Again, you can look them up for it. And if any of these interest you, you can look them up and write about them, right? So Djibouti in Africa, right? In Chile. You can see here we have Baja, California, Mexico, and the whole Pacific coast, all that stuff. Look it up. Another thing that surprises me, and I might look this up. I don't know why I've never noticed this before. See New Zealand. Okay, I was about to say there's no Australia, but there's a little chunk of Australia. But most of Australia, according to that, is not a biodiversity hotspot. Anyway, any questions about this? Oh yeah, you might not be able to see it, but Hawaii is a biodiversity hotspot too. There's actually a lot of little tiny islands in the Pacific that are biodiversity hotspots. They're so small they don't show up on the map. I've been to some of them. All right, next thing we're talking about is conservation at the ecosystem level. Conservation biology aims at sustaining the biodiversity of communities, ecosystems, and landscapes. You already know what a community is, right? So a community is a step up from a population, remember? So a population is just like a bunch of the same species living together in the same area, interbreeding, dealing with the same things. That's just one species, right? A step up from that is a community, which is all the species interacting together. A step up from that is the ecosystem, which is it's a community, but now we're also considering all the non-living things that affect the living things. The weather, the climate, that is, the pH of the soil, the sound pollution from the roads, the actual pollution from the chemical plants next to us, that kind of stuff. And then the next step up, and I haven't taught you this yet, so here's a new term you need to understand, landscapes. It's a step up from ecosystems. So basically, before I even read what the book says, basically you can just think of the same way an ecosystem is all the living things and how they interact with each other and also how they interact with the non-living things, right? It's all about interaction. Well, a landscape should be pretty intuitive. It's a step up from that. So it's all these different ecosystems and how they interact with each other. These ecosystems aren't like in their own little world, cut off from everything else, right? All these ecosystems interact with each other. The same way different species, different populations interact with each other. So anyway, if you remember that for the exam, you're good, but let's talk about how your book defines it. Landscapes are regional assemblages of interacting ecosystems, such as an area with forest, adjacent fields, wetlands, streams, and streamside habitats. If you're writing this down, really, that's the part you need to know, right? The rest is just examples. Landscapes are regional assemblages of interacting ecosystems. So in this area, this landscape, we have a lot of that. So across the street, we have a forest ecosystem. Behind us, we have a river ecosystem. Where we're at is kind of an urban ecosystem. Maybe you might consider the fields, like the football field in that area, the baseball fields, all those areas back there, you might consider that fields, but not quite, because it's more like a human ecosystem, a human-dominated ecosystem. And there's like the area in between the rivers and the woods. That in itself is its own ecosystem. Anyway, that's a landscape. It's all these different ecosystems interacting with each other. So that brings us to what landscape ecology is. That is the application of ecological principles to the study of land use patterns. And the goal of it is to make conservation a functional part of planning for land use. So when they want to build something new in this area, for example, somebody who knows more than I do is going to look at these landscapes and figure out how all these different ecosystems interact with each other. And then for them to get a permit to do something here, if it's something big, then they would have to go through this and see what kind of effect they're going to have on the ecosystem around here. So anyway, any questions about this slide? All right, if there's no questions about this slide, we'll move forward. I like that your book points this out because I accidentally already said it earlier, but there's also these edges in between ecosystems themselves are unique. So how many of you like to go hiking through the woods, or at least have enough to remember what it's like? Right? So you know, like when you're in an open field or a parking lot or whatever, and you first get into the woods, there's a lot of brushes, right? It's really thick. I mean, usually there's a trail, and that part's not thick, but you can see it's thick. And then once you get into the woods, it's like all trees, and it's easy to walk around through the woods. That's the edge, right? That's the edge of an ecosystem, or two ecosystems. That's just one example. So things that grow there at the edge of the woods don't grow in the woods or in the field, right? It's a unique ecosystem in itself. Same thing with, like you have the ocean, then you have the land, right? Two different ecosystems. And then you have the beach, which is where the ocean meets the land. That in itself is its own ecosystem, with its own unique properties and its own unique species, some of which are overlap. But anyway, the edges between ecosystems are prominent features of landscapes, whether natural or altered by people. So again, using the baseball fields and football fields as an example. Yes, that's not natural, but it is a field. And where the field meets the woods, that area, that edge between, that's its own unique ecosystem. They have their own physical conditions, like I already said, such as soil type and surface features. So again, another good example of this is think about like, where there used to be a forest, we went and cut a road through there, right? And that in itself is its own ecosystem. And then we apply salt in the winter, so you have to imagine all the water that's running off that road and then making its way to the edge of the forest. That's got its own unique physical conditions, right? The soil conditions there have to be different because they're crushed by cars and polluted by salt and all that other stuff. Anyway, any questions about the edges between ecosystems? The next slide is going to be a picture of a couple of them, just as an example. So here's some natural edges. Here's some on the left. There's some human created on the right. So here's the natural field. Right, think about all the species that live in this field. Those species are going to be unique, sort of. Some of them will be unique, right? Things that live, like all these plants, those are grasses, right? And all the things that live in the grasses. Versus the woods, right? Those are different species, different plant species, different animal species that live in the woods. And this little area between where the field meets the woods, that in itself is its own unique ecosystem. Of course, obviously, a river is its own ecosystem, a lot different than the field or the woods. And then here, this is basically the same thing, except instead of having these natural fields, we can see these are man-made fields, but it's still, the concept still applies. You've got fields, and then you've got woods, and you've got that little strip in between. Anyway, any questions about that? All right. An important feature is something called a movement corridor. And you need to know what this is. Possibly I might ask about this on the exam. It's a narrow strip or series of small clumps of habitat, that connect otherwise isolated patches. In that last picture I showed you, I actually had some movement corridors. So I'm going to back up really quickly, show you that, and then come back to this slide. Let me back up one slide. So you can see here, we got a woodland and a bunch of fields and then woodland, right? But you can see this little strips of woods, right? So that is the movement corridor. So species that like the woods, that don't like the open field, can now get from this clump of land to this clump of land. And without it, for the most part, they couldn't. I don't know, maybe it's a species that doesn't want to get eaten by a hawk or something like that, so it doesn't like being flying in the open, for example. Whatever the case may be. Anyway, that's a movement corridor. And it can be good, it usually is good, because it can promote dispersal, meaning it can help these animals and plants get where they need to go. Which is good because it can help sustain populations. So this is obviously going to be even more important for some species than others. For example, it will be important to species that migrate between different habitats. So obviously, if you have a species that's just fine with being in one spot, and that's it, it's going to be less important. But some species really do need to move. And I'm going to give an example for that. I think when we jump back and go to chapter 19, I'm going to give you a really good example of a species that needs to migrate. But we'll talk about it. Excuse me, let me back out of this and make sure we're still recording because I heard noise. Anyway, so yeah, these are all ways that movement corridors are good. All of these bullet points other than the last one, right? This is how movement corridors are good. Of course, they can be bad in a way because they can also spread disease, especially among small subpopulations and closely situated habitat patches. So yes, mostly they're good, but also they could be bad. Of course, that's pretty much anything in nature. So any questions about this slide? All right. Let's say the next sentence word is small. Here's a man-made movement corridor. And you can look these up for independent work too, because I've seen these too. Now I am curious, because you would actually be teaching me something. Where do you find these? Like, I know some examples, but I'm very curious. Like, there might be some website that gives you a whole list of exactly where you can find all of them. But yeah, so this looks like a regular bridge, but if you were to see it from up here, which I don't know why the photographer didn't do that, you can see that it's a strip of land. It's not like a sidewalk or a road. And again, movement corridors, right? So you have all these open fields. Let's pretend like right here, what you can't see off screen is a big forest. So you have a forest here, you've got fields here, and you have a forest here. And if you're a species that needs to live in the forest and you can't migrate over open fields, then these movement corridors are going to be perfect for you. And I know that sounds weird, because unless you're an ornithologist, you might not think about that. Like if you're thinking about birds, you might just think, yeah, just fly over there. And it's not that simple. Species are very interesting, very different. Some of them just can't fly or won't fly in an open field. Another good independent work topic. All right, let's talk about restoring ecosystems as opposed to preventing destruction of them. And that brings us to another term you might need to know for the exam, which is bioremediation. It's in the name. Bio means life or living. Remediation means fixing something, right? So bioremediation is going to use living organisms to detoxify polluted ecosystems. But for the exam, you could just think, using living organisms to fix stuff. That's close enough. Because on this multiple choice exam, the question is, the choices aren't going to be bioremediation, living organisms used to clean polluted ecosystems, or detoxify polluted ecosystems, or remediate polluted ecosystems, right? I'm not going to get that specific. So if you can just remember, bioremediation is using living things to basically clean up a human's mess. And that's what we're talking about. You definitely don't need to know the examples. but your book examples are. We use bacteria that have been used to clean up old mining sites and spills and oil spills. And this one's kind of interesting to me, the second bullet point. Plants that have been used to remove toxic substances such as heavy metals and organic pollutants. So we have Dr. Amos, who works here in the biology department. That's what he works on. He works on plants that can remove heavy metals from what used to be coal mining sites. So rather than just saying, coal mining's bad, you shouldn't do it. Some people do make that fight, but we also look at the other end. Like, well, we're gonna be coal mining, so how can we fix the problems that we make by coal mining? And again, we do that here in this building. Well, the researchers in this building, obviously, he's doing his research. There's also some other examples. This is another good independent work topic. You can look into it. This is like cutting edge technology, not what's here, but if you were to follow any kind of science newspaper like I do or a magazine, they're all the time coming up with these new species that like, oh, this bacteria can eat styrofoam, or this bacteria can eat plastic. So there's a lot of new stuff coming out if you want to look into that. Any questions about what bioremediation is? Using living things to clean up our mess. This guy's, no, I'm just kidding. Anyway, so if I remember correctly, this guy is a scientist who planted these flowers. I forget exactly what kind they are. But if I remember correctly, they're good at pulling toxins out of soil. If you read your textbook, there's a little caption that tells you exactly what he does. I don't remember. Obviously, I'm not going to test you on it. So some projects have the broader goal of returning ecosystems to their natural state. So in some situations, we just want to completely undo what humans have done. Not just clean up our mess, right? So like if you have an oil spill on the coast of California and you clean up the oil, well, you haven't really returned it back to its natural state. You still have beach houses and businesses and things like that, but you cleaned up your mess. But what we're going to talk about here, it's just an example, I'm not going to ask you about it, it's completely returning things back to the way they used to be. And this one hits close to home for me because I used to live in Florida. Anyway, there's a place called the Kissimmee River. It used to be a very shallow, meandering river. So when I talk about meandering, I'm talking about like a lot of curves and stuff. But what happened is, around 60 years ago, they straightened that river into a canal. So it's no longer shallow, it's no longer meandering, it's a straight shot of water. One, because they needed water for the humans that live in South Florida to drink. Two, they needed water for their agriculture. And three, they just needed transportation, right? So it's easier to get down that canal. So that's why they did it. I don't think your book even talks about that. But it was not good, right? It was bad. What happened in doing that, they drained about 31,000 acres of wetlands. And again, this is just an example. I'm not going to ask you about this. Drained about 31,000 acres of wetland, which had a significant negative impact on the fish and wetland bird population, obviously. So if you are a species that lives in the wetlands and they drain the wetlands, you're obviously out of a place to live and you die. Or you can migrate to another wetland that's close by that already has its fill, right? It already has a full population. So then you just have extra animals and different species coming in, and then they're going to compete and some are going to die. So it's not a good thing. Anyway, they started a restoration project that involved removing the water control structures. Again, this is just an example. I'm not going to ask you to do this. So they had things like dams and reservoirs, channel modifications to help straighten it. They got rid of all that. They filled in about 35 kilometers of the canal. And the first phase was completed in 2004. And when that happened, back in 2004, the wildlife returned in unexpected numbers. So they were a little bit pessimistic about what should happen, because once it did happen, it happened, it improved better than they thought it would. Then the marshes were filled with native vegetation and game fishes back in the river. So there you go. Again, I'm not going to ask you a question about that. Here's some pictures of what I'm talking about. That's where it goes from Lake Kissimmee to Lake Okeechobee. You can see this is where the canal used to be. And like we've said, they filled it in, and then things kind of went back to normal. And you might not be a fish expert, but a fish that lives in the canal, like clear, fast-moving, straight water, is probably different than the species that would be living in a shallow, meandering river. Some of them would be the same, some of them would overlap, but some of them would be different. Anyway, any questions about that? All right, the last bullet point of this chapter, before we back up and jump into chapter 19. We're going to talk about the goal of sustainable development. As the world population grows and becomes more affluent, meaning basically richer, right, access to more resources, at least the money to buy those resources, the demand increases for ecosystem services, such as food, wood, water, a bunch of other stuff. No, you don't need to write any of this down. This slide is just an introduction. Actually, maybe this bullet point. Maybe I'll ask you this. So what is the goal of sustainable development? It's to meet the needs of today without limiting the ability of future generations to meet their needs. And if you take Bio 108, that's basically the whole semester can almost be boiled down to that. Sustainability. It's literally a matter of life and death. Not necessarily imminently, right? I'm not saying if we don't stop using coal tomorrow, we're going to die in 2 weeks. But it's not sustainable, meaning we can't keep doing it. That's just one of many things, a lot of things. I'm not picking on coal. I'm just using coal as an example because we're all familiar with it because of where we are. So yeah, basically you need to know what sustainability is. Basically, it's the ability to do what we're doing, to continue to do it. So for example, if we're talking about fisheries that are a great example, if you're catching more fish that are being reproduced every year, that's not sustainable, right? Because the population is going to go down, 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 down until we hit zero. And essentially, a lot of bad stuff we're doing for the environment is what's happening there. Think back to the ecological footprint lab we just did this week. So if your ecological footprint is larger than the biocapacity, you're taking more resources that are being produced. So eventually, we're going to run out. That's all that is saying. Any questions about that side? All right. So sustainable development depends on continued research. I'm not going to ask you any of this stuff either. This is just for your own knowledge. Anyway, it depends on continued research, the application of ecological knowledge, and the connection of life sciences with social sciences, economics, and humanities. And I love this. And like I said, I'm doing an experiment by doing chapter 20 before 19. But this is generally where the whole course would end, which is a great place to end it. I love this because this talks about only one of these biology major. So this is important, right? So this kind of shows all this stuff you just spent learning all semester. It's important for all of you, not because you're biology majors, because you're not, but because this affects everything. And this is also, and I said this on day one when we first started this course. I was talking about why do you even have to have a bachelor's degree? Why do you take all these courses that have nothing to do with your major? And I like how this kind of sums it all up, right? We need all these things. We need to learn about social sciences and economics and humanities. We need all this basically to survive. So as a college-educated student, hopefully you'll have all these. It'll be a productive member of society. Also kind of goes back to this. Sustainable development aims to conserve biodiversity and improve the human condition. I like these because those have to be together. Because we could easily conserve biodiversity if we just didn't care about human conditions, right? We'd be like, all right, we've got to conserve biodiversity. So from now on, you can only have one refrigerator in your household. No more taking vacations. No more concerts. Right? Think about all the bad things that we do for the environment that aren't necessary for our survival. If we weren't concerned about the human condition, we could just say, all right, we're outlawing all these things. But we don't, right? We want to conserve the environment because we have to live. We need to conserve biodiversity. But we also need to do it in such a way that we can live and enjoy our lives, right? Anyway, to do this, we got public education, that's you guys, political commitment, which maybe you guys, or maybe you guys one day, and the cooperation of nations that are essential to success. So the awareness of our ability to alter the biosphere and jeopardize the existence of other species, as well as our own, may help us choose a path towards a sustainable future. I love this because, like I said, sustainability is a matter of life and death. And I'm not using that as a scare tactic and saying we're all going to die in 2 years if we don't stop using straws. I'm not saying that. I'm just saying overall it is a matter of life and death. And hopefully the fact that you guys are learning this will help with that. And this also goes back to my Bio 108 class. And I think I posted something about this on Google Classroom or Facebook recently, where my job in the last part of this course, and then all of Bio 108 is to teach you, all right, this is good for the environment, this is bad for the environment. I'm not saying don't do this because it's bad, and you better do this because it's good. I'm just saying, I'm giving you the knowledge so you can make your own decisions on what you're going to do, what you're not going to do, what you're going to purchase versus what you're not going to purchase, who you're going to vote for versus who you're not going to vote for. At least now you have a more educated decision. Anyway, let's jump into chapter 19. I know you guys probably not what you want to hear on Friday, but yeah, we got 7 minutes. I can at least get a good chapter 19 introduction going. Are there any questions while I'm pulling this up? Does anybody here listen to 102.7? Mm-hmm. You guys do? You listen? Do you know the code? No. I need the code. I'm trying one of those tickets for my daughters and my wife. You guys give me the codes. I'll give you extra credit. I know the first two digits. Do what?
I said more like it. We won't use those tickets. That's more like $5.
There you go. Yeah. Give me the tickets. That one. Then we're really talking. Would you get an F in the course? No, that's an A. I'm just kidding. Don't quote me on that, even though I'm being recorded. I want those tickets. Oh, this is powerful. Sorry, guys. I'm trying to pull it up. You can tell I'm used to the computer downstairs, not this one here. There we go.
Down one more. Down.
Try one more thing before we quit here. There we go. Chapter 19. So again, as far as you guys are concerned, the fact that we went from 20 to 19 shouldn't make a difference. A lot of the information in 19 is not necessarily important to understand 20, and it is, but at the same time, some of the information for 20 is important to understand 19. So that's why I'm doing this experiment, to see how you guys do, if you do any better or worse than the class before you. So here we go. Now we're going to talk about population ecology. So again, chapter 20 was a really big picture, right? We weren't just talking about a population. We were talking about ecosystems, right? And landscapes, which are a bunch of ecosystems interacting. So now we're kind of like backing up and looking at a smaller scale again. Not very small, but small. We're looking at populations. We're going to skip this, why population ecology matters. We're short on fish, or short on time. We're also going to skip this, as we always do, biology and society. You can look this up. Not just this, but you can look up lionfish, because it's an interesting story about an invasive species, or any invasive species you want. They're really interesting. When I was in Guam, when I first got to Guam, I noticed it was like, this is when I was really young, so I didn't know anything about it. I wasn't a biologist. There's no birds on Guam. I was like, what the hell? What's up with that? Oh, sorry for my language. Anyway, come to find out later, as an adult, the reason that there's no birds on Guam is because there was an invasive snake that made its way to Guam in World War II, because it would like hop on the airplanes and hop on ships, and that's how it made it. It killed all the birds. And now they're killing those snakes by dropping dead mice out of helicopters with little parachutes. The dead mice have been laced with Tylenol, and it kills the snake by destroying the liver. So there's all kinds of interesting invasive species stories. Anyway, let's talk about an overview of population ecology. Let's get this introduction knocked out anyway. We can do this really quick, because we've been talking about this a lot in chapter 20, so you already know what a population is. It's a group of individuals of the same species that occupy the same area at the same time. So all the squirrels in WVSU's campus, I always use that example, right? That's a population. Same species, same place, same time. They're competing for the same resources. They're influenced by the same environmental factors. So if there's if a blizzard hits WVSU's campus, that's going to affect the population of squirrels on WVSU, but it's not going to affect the population of squirrels on the University of Georgia's campus, right? It's a completely different area. Same species, not the same population. And they're likely to interact with each other. So again, population, same species, interacting with each other, dealing with the same things, competing for the same resources. So now that you know, again, what a population is, what's population ecology? I probably won't ask you this because we're just going to talk about it. But a population ecology is concerned with the changes in the population size and the factors that make that happen, right? So population ecology is like basically looking at this population, a certain species, and looking at how it's growing or shrinking, and what's causing it to grow or shrink. Definitely don't need to write these down, because we're gonna talk about these individually. But when we talk about a population, we can describe them generally by four things. The size of the population, and that's usually the one we talk about, right? Like there's about 8 billion humans on Earth. That's the size. The age structure. Here's an independent work topic because I don't know the answer to this. What is the age structure for humans on Earth? Is it like, what do we have most of? Do we have mostly old people, mostly young people, mostly middle-aged people? I don't know. Density, obviously, that's like, all right, there's 1 million people per 1,000 people per square mile, whatever it is. But anyway, we're going to talk about this individually. For this slide, you just need to know what population ecology is. Population ecology, again, looks at the growth and decline of a population and what causes it to do that. There's some pictures show a little bit of that in action. Population dynamics. That's the interaction between the biotic and abiotic factors that cause the variation of population size. So again, population ecology is looking at the way population size changes, but also the things that cause that change, and that's what population dynamics is. It's the things that cause that change, the living and non-living things that affect the population, right? So malaria would be a living thing that affects the human population. Global warming, well, we won't have time to talk about that. Anyway, an important aspect of population dynamics is population growth. Again, that's mostly what we're focused on, is how the population grows and shrinks. Size would be the next attendance word. Population ecology, there's no need to write any of this down, this is just telling you why it's important. Population ecology plays a key role in applied research. So it provides information for conservation and restoration projects. So again, when coal mines remove a mountain, they're not allowed to just go out there and do it willy-nilly. They have rules they have to follow when they destroy it, and then when they restore it, right? This is all very regulated. It's used to develop fisheries. So we have fisheries here in West Virginia. That's why you have to pay for a fishing license, because they do develop fisheries. If it wasn't for the DNR putting fish into our streams, most likely we wouldn't have really anything to catch. Similarly, it's used to manage wildlife populations. So again, deer hunting, things like that, or bringing elk back into West Virginia, which is something that happened recently that you can look into for independent work, and provides insight in controlling how pests and pathogens are spread. So tree of heaven, well, we'll just leave it there. And we'll talk about that last bullet point when we get back. So you guys have a good weekend. Get some independent work done. Sunday's the last day to do it. And if you guys know anybody in this class who's never here, remind them, just running out of time, read the announcements, because it's free points out there. Some people have like 0 points of independent work. And I keep saying read the announcements to get those 3 points, but they're not doing it. I can step up and go to my office now. Oh, sorry. Okay, I can hear it. Okay, yeah, it wasn't just you. I understand. So.